Hello friends, welcome to this episode of Science for Common Man. And today's question is, how is a rainbow formed? And in this episode, you can expect explanations on how different colors coexist with a white light with an interesting analogy. Easiest explanations for refraction and dispersion leading to the formation of colors, and the physics of formation of rainbow, and what are the conditions that need to be satisfied for the formation of rainbow, and why the shape of the rainbow is always in an arc, and is it possible to see a fully circular rainbow. And remember, this is Science for Common Man, no equations here, only physics here. Let us jump into the world of colors. I have green color here and red color here, and see what happens when I mix the red color and the green color together. It gives rise to yellow color. And now I am adding a third color, that is blue, to it. And see what happens when all the three colors are combined. It gives rise to white color. So that means in white color there exists red, green and blue. Now if I change the intensity of these colors in different orders, I can see that I can form different colors with a combination of these three colors. Here I have white light and I am removing the blue part of it. Now see what it becomes. Now I am removing the red part of it. Now see what it becomes. So this is how different colors coexist within white light. And science says that the different colors can be differentiated by their wavelength. The wavelength is something which is associated with how the light travels. Let us not worry about that. Consider white light as a group of people of different colors with different lengths of the leg, or I say different leg lengths. Let us say that violet is the person with the shortest leg length. That means in one cycle, violet will cover the shortest distance. And let us say the red light is the person with the longest leg length. That means in one cycle, red light will cover the maximum distance. Whenever we see light as white, it means that all these people with different leg lengths and different colors are walking together. Let us see what happens when they travel from one medium to the other medium. For this, let us see another interesting analogy. Let us see a cylindrical barrel rolling from one surface to the other surface. Let us assume that the first surface in which it is rolling is a concrete surface, and the second surface into which it rolls is a grassy surface. Now in the concrete surface, you know that friction will be less, it will be easy for it to roll, and as it enters the grassy surface, its speed should reduce. Consider that the cylindrical barrel is rolling straight from the concrete surface into the grassy surface. In this case, as it crosses the boundary, the speed of the cylindrical barrel reduces. The speed of the rolling reduces, but it continues to travel straight because the direction of its travel is perpendicular to the interface. Now let us consider that the cylindrical barrel is rolling at an angle to the surface. Now what happens here? When the cylindrical barrel rolls from the concrete surface to the surface with grass, now first some of its parts, some of its edges come to contact with the grassy surface, and those edges slow down first, which cause a tilt in the barrel. And it shows that when the barrel rolls from a concrete surface to the grassy surface, it just makes a tilt on the interface. You can see when the cylindrical barrel, when it rolls from the concrete surface to the grassy surface with an angle, this particular interface produces a tilt in its path and it continues to go straight after tilting. This is what happens when white light travels from one medium to the other medium. If it is traveling perpendicular to the interface, nothing happens to the direction, but its speed reduces and it continues traveling straight. But at the same time, if it travels towards the interface at an angle, at the interface, the direction changes and it goes in other direction to the second medium. This particular phenomena is called refraction. We have already seen that white light is a group of people with different colors and different leg lengths. Let us consider a case where this white light is traveling from one medium to the other medium. So these different people are approaching the medium. If they are approaching at an angle which is perpendicular to the interface, they go straight and with a reduced speed. If they approach the interface at an angle, it's interesting to see what happens. Now the different people with the different leg lengths find different easiest way in the new medium. And as a result, this flock of people diverges and the white light splits into different colors based on the wavelength or the leg length of the people. This phenomena is called dispersion. Let us consider a case where we have sun here and a set of raindrops or water drops suspended in the air. Let us see what happens when sunlight or white light enters into a raindrop which is suspended in the atmosphere. Some part of the light gets reflected. We are not worried about that. Now consider the other part which gets into it. Here white light disperses into different colors as we explained earlier. We know that violet has the shortest leg length and red has the longest leg length. So based on that, violet bends to the maximum and red light bends to the minimum. Now let us see what happens when this diverging light meets the back end of the raindrop. Some part of the light refracts through the back surface of the raindrop and we are not worried about that, but the remaining part gets reflected from the back surface of the raindrop. And that diverging ray comes to the front surface of the raindrop, and on that surface it further gets diverged and it travels at a diverging angle to the atmosphere. And if you see the total angle that the light gets bent on this complete process, you can see that it is from 40 to 42 degrees. As we see, these diverging colors are further traveling in the atmosphere. So if I stand in their way, I will be able to see these colors. If I stand in the way in such that the red color is entering my eyes, I will see this particular raindrop as red. Since the different colors are diverging, I will never be able to see the different colors coming from the same raindrop. Now consider another raindrop which is lying lower to the earlier raindrop. Depending upon the observer's location, violet color may be entering my eye. Then I will see that particular drop as violet. And if I see the cloud of raindrops which is available between this red drop and the violet drop, I will see the different colors. So these drops appear in different colors to an observer standing here. So these are the conditions to be satisfied for the formation of raindrop. 1. Your light source should be in your back at a considerable distance. You should have water drops suspended in the atmosphere. This light rays falling on the water drops will make a total bend of 40 to 42 degrees, and these rays will be traveling in a diverging manner, and you should be standing in the path of those rays to see the rainbow. So wherever these three conditions are met, you will be able to see beautiful rainbows. Another question is why the shape of the rainbow is always of that of an arc. To understand this in detail, let us consider a situation where I am traveling in an aeroplane through the atmosphere. Now, let us say ahead of me there is a cloud of water particles, there is a cloud of suspended water particles available in the atmosphere, and in the back of me I have the glowing sun. In this condition, let us see what happens. The light from the sun enters into the raindrop and it makes a bend of 40 to 42 degrees, and since I am on the path, I will be able to see a rainbow forming at this location. What about this location? Here also the light from the sun will be entering and light rays will bend by 40 to 42 degrees, and that rays also will reach my eyes and I will see a rainbow here also. So in this particular case, I will be able to see a fully circular rainbow like this. But unless we are that high in the atmosphere, we will never be able to see a fully circular rainbow like this. In a normal scenario, since we are on the ground, we are seeing only a portion of the circular rainbow which appears to us as an arc. So if I am traveling in an aeroplane high in the atmosphere, I will be able to see a fully circular rainbow provided I have sun in my back and a cloud of water particles suspended ahead of me. In the same conditions, if I travel down to the ground, the parts of the circular rainbow will go under the ground and I will be able to see only this top part which is in the shape of an arc. That is why while standing on the earth, we always observe rainbow in the shape of an arc. Let us rewind the points. First one, different colors coexist within white light based on different leg lengths. Refraction and dispersion can be thought of a cylindrical barrel rolling from a concrete surface to the grassy surface. Third one, the conditions need to be there for the formation of rainbow. Yes, we will be able to see a fully circular rainbow if we are high up in the atmosphere. In the ground, we always see it as an arc. Thank you for watching. Hope you liked it. Please do subscribe and click the bell button to receive notifications about the future videos. Thank you. Signing off. Remember, this is Science for Common Man.